Then for our T, which is equal to stress times the area, of course we have our stress, which is 864,000, multiplied to the area, which is thickness times the height. Therefore, if we try to substitute, we have 864,000. Our T is 1/2 inch, convert that one to feet, so 1/2 times 1 all over 12 times our H, and this gives us 36,000 H. Then from our equation, summation of forces equal to 0, we have F is equal to 2T. We try to substitute the value for F, which is 1,372.8 H squared is equal to 2 times 36,000 of H. Upon simplification, our H is 52.45 feet. Problem number 3, the strength of longitudinal joint as shown in the figure is 33 kips per feet, whereas for the girth it is 16 kips per feet. Calculate the maximum diameter of the cylinder tank if the internal pressure is 150 psi. So we are given with the force on the longitudinal joint, which is 33 kips per feet, and on the girth this is 16 kips per feet, and we are given with the internal pressure, which is 150 psi. So let's convert our internal pressure to pounds per square feet. So internal pressure is equal to 150 pounds per square inch times 12 inches over feet. So raised to the second, so we get now 21,600 pounds per square feet. So we have our internal pressure. And for the longitudinal joint, for this one, longitudinal joint, on the tangential stress, so we consider a 1 feet length. So of course we have F is equal to 2T, and F is equal to internal pressure times the diameter. Since we are considering 1 meter length, so and then we have equivalent to 2 times our force would be stress times our thickness. So this can be equivalent to stress is equal to P D all over 2T. We try to substitute the values for the longitudinal joint. We have our force, which is stress here is force all over the area. So force is 33,000 all over the area, since we consider 1 feet length. So this is all over T, which is equal to 21,600 times D all over 2T. So therefore, our D here is equivalent to 3.06 feet, which is equivalent to 36.67 inches. For the girth joint, so we have here, for the girth joint, we have F is equal to P, and our F here is internal pressure times the area, which is pi d squared all over 4, and this will give us P, which is stress times pi times area d times T, and our stress here is equal to internal pressure times D all over our 4T. So for the girth, we have our force, which is 16 kips per feet, or 16,000 all over the area, which is T, since we T times 1, since we consider a 1 feet length, is equal to 21,600 D all over 40. So our D here actually is equal to 2.96, or this is in feet, or this is actually equal to 35.56 inches. So therefore, we use the smaller value in diameter. So our D here is equivalent to 35.56 inches. So this is our final answer for the maximum diameter of the cylinder tank if the pressure is 150 psi.